Okay, good day, guys. Today's January 8th. Let's do it to it. Okay, so for today's lesson, we're going to, again, review this and then do some more inequalities. We do two more of these for Alamari. Okay, so first off, I'm going to always go with domain and range, just keeping with that, Domain, I'm going to go with X, and then it's going to be between, what, two numbers? So I'm going to go, again, I'm looking strictly when I go left and right here, off the x-axis. You see how there's no more graph over here and no more graph over here? And the graph only exists here. So what I'm trying to get here is that if I get any coordinate from here, here, any point, the x values, where could my x values be? Well, they'll always have between 1, 2, 3, 4, a -4, and a 1, 2, 3, 4, 5, 6, 7, and a 7. See how it's shaded in, or it's not like an open circle like this? And I'm going to go and say it's included for both sides. That's it. Any coordinate I get will have an x value between a -4 and a 7. And that means decimals and everything. Okay? That's why I'm going to see it like that. And just take it easy. Don't freak out. Now, range are your y values. And our y values are between two numbers. Now here, I'm just looking for the y-axis. See, this is how high and how low. There's no graph over here, there's no graph over here. So my y values, any coordinate anywhere, any kind of x, y, I'm looking strictly at the y's. The lowest my y's would go would be a -1, 2, 3, 4, 5, 6, 7. And the highest it would go would be a -1, -2. This one, you see how it's open here? So that's saying that don't include it. So you do not put the equal sign. The highest one is a solid line that goes through there. So we're going to go and say it is included. There's my domain or my range for that. Domain, range again. We'll try this real quick. Domain, my x values are between what two numbers? The lowest. Now again, I'm going to go off the x-axis. So I'm saying, you see this arrow? The lowest would be, well, forever in that direction. Now, I can't say -1, -2, -10, -30 because the arrow here means that it goes on forever. Just look at this. You see how it has a little slight, slope going up, and it definitely has a lot of slope going this way. So it really goes up forever in that direction, and it goes forever in that direction. And let me see. And then here is like its starting point. So the least it would be is to a negative infinity. The most it would be what? X-axis, what is that, 0? And there's my answer right there. Oh, it is included, so I'm going to go right here. So I'm going to tell you this much. This is saying any x value that's less than or equal to 0. So we're just going to throw this as my final answer. Does that make sense? Any x value less than 0 or equal to it. That's what that says. You could say it goes up into negative infinity, but this also includes that, so we're just going to leave it like this. Range, that's going to be my y values, like this, and like this. This one right here, lowest value, and then the highest value. Again, since it has a little slope pointing, like, a little slope up, it goes forever in that direction. So the lowest this one would go would be 0, and I want to say it's included, and it goes up into positive forever and ever, infinity. What I'll say here is I'm just going to say this part right here. Now I'm going to switch it around. I'm going to say y, okay? See how it's eating the y? Greater than or equal to 0. Y, as long as it's what? Greater than or equal to 0. Greater than 0, any of these y values are greater than 0. And then right here means it's equal to it too. That means it starts off there. And yes, it does. Okay, let's go to today's lesson. Now we're going back to the book. We're talking about inequalities. So remember we said here, less than, fewer than, greater than, more than, this right here. These are the words that can kind of, mean this when you read words like this. So we're going to write inequalities over this stuff. Quick review. Remember, if we had variables like this on either side, subtract the smaller one, wind up with this idea here. To graph that, flip that around as a is greater than the negative 6. This part here, make sure you write it, the arrow pointing to the right, going to the right, and then shade it in. And from where? A 6. This is the answer. The set is A such that A is greater than or equal to a 6. And there it is. A is any A value as long as it's going to be what? Greater than or equal to 6. And all this like blue line means like any answer from here. Any of these answers, and they put the arrow because it means it goes on forever in that direction. We left off here yesterday. Okay, going into words. So let's come back to the words. See what's going on with the words. So, Felipe needs, for the control of his leopard gecko, right here, basket spot to be at least 82 degrees. So it has to be like kind of warm, right? Currently the basket spot is 62.5. How much warmer does the basket spot need to be? So we're going to come out here and say, well, it's current temperature. It needs to be at this much. So we're going to kind of look at this stuff here. The current temperature is going to go, we're going to go with T for temperature, right? And the temperature is what, 62.5? And how much more do we need to add to it? Since obviously we need to make it go up, right? So 62 plus the needed amount. And it has to be at least. So if you think about this, this is the temperature, and this is what the limit is. We want the temperature of what to the limit? We want it greater, or do we want it less? Actually, it says at least. So that means that's going to be our lowest spot. So we want this side over here to be greater. So we set it up where you have to read this and make sense of this case. At least. So when this part here means this part is going to be greater than that. Is it included? Can it be 82 degrees? At least 82 degrees. Yes, it does. It doesn't say more than 82 degrees. It says at least. So 82 is included. So we'll put the equal sign down there on the bottom. Set it up. Do your math. Minus 62.5, minus 60.5. So 19.5 is the answer. What does that mean for us? That means if we have 19.5 and we add it to the current temperature, it would be at 82 degrees. And that's the least we'd want for that basket spot. So can it be something greater? Yes. As long as it's a little bit greater, cool. Can it be here in a situation where it's equal to? Yes. Let's practice this real quick. Now, don't worry if you don't get it. Just practice makes perfect. Sanjay has $65 to spend at the mall. He bought a T-shirt for $18 and a belt for $14. If Sanjay wants a pair of jeans, how much can he spend? Okay, so let's think about this real quick. I'm going to go with 18, you know, what he has spent for the belt, and 14 where he has, oh, I'm sorry, for the T-shirt, and 14 for the belt. That makes sense. And he has $65. Now, let's think about this. This is what he's going to spend, or here's what he's spending. And this is what he has. So just think about this in your head. Somebody already had the answer already. You know how to do this. If I put this symbol here, I'm just going to go with this one. This says 65 is the most, the bigger one. Can he spend 65 or more? Is 65 the upper limit that he can spend? Think about that. Is that the most he can spend? Since this is greater, can he spend less? If you think about this. I'm going to say yes. He can spend less over here. I'm going to reverse this symbol right here real quick. This is how I'll do it. You know, I'm not professional. I'm not the best at this thing. So this one says this one's more, and this is what he has. So this one's less. Like think about this one. He can spend more than what he has. He can spend more than what he has. Okay, let's look at the story again. He has 65 to spend at the mall. So that's all he has. That's all he has. I don't think he can spend more. He bought a T-shirt for $18 and a belt for $14. He wants a pair of jeans. How much can he spend for the pair of jeans, right? Okay, so let's look at this one. Can he spend more than 65? So I'm going to say no. This setup would be wrong. So this is the most he has. and this one would be less. Do you agree? So he can spend less, right? He also has this. Do you agree? He also wants a pair of jeans. Now I want to tell you this much. Can he spend all of 65? Hold on real fast. Okay, so we come back here. Can you spend at the whole 65? I want to say yes. You just work this out right here. So I'm going to step to the side real quick. So we're going to J that counts the jeans that he wants. He already has spent 18 and 14. And he can't spend any more than that. 65 is the most. And he can spend the whole 65. I'm going to add these up real quick. Keep in mind it's a 12, 32. So the jeans plus 32 is less than or equal to 65. Minus 32. Minus 32 that he's already spent for the shirt and the belt. Jeans, $33. He can spend up to $33 for a pair of jeans. Pretty cool, right? He can buy jeans for $1, $2, all the way to $33. He can't go over $33 because then he'd be going over 65. Okay, guys, so today we're doing 5.2, solving inequalities by multiplication and division. And I'm going to tell you this much, these things are the same. They're basically the same, I promise. So if you know how to do one, you know how to do the other. Remember I was saying last time, if you add, that's like subtracting, or subtracting is like adding because you're adding the negative. Same thing here. If you're multiplying by a number. If you're dividing, you're multiplying by the inverse. And that's it. Really simple. So we're going to solve linear inequalities by multiplication, solve linear inequalities by using division. Now so if you have a true statement here and you multiply each side by a whatever number, it stays true. It has to be the same number, right? We know how to do that. Now what happens if you multiply by a negative? Okay, so if I have a 7, and you see how that one's less than a 9, and if I multiply by a negative, well, what happens is if we multiply these out and we keep the symbol the same, it's going to be wrong. Look. If I already keep this symbol the same, is that true or false? That's a false statement, okay? So for it to be true, we're going to have to do this now. When you multiply by a negative or divide by a negative, you have to switch the inequality sign, okay? So here we go. So just copy. Let me zoom out a little bit, and I'll talk to you about it. So you pause it here, and I'm going to just save us some time, okay? Multiplication and division. Symbols, okay? So what this part says here, if you have an inequality and it's true, and you multiply by a positive number, you keep the inequality sign the same. That's it, keep it the same. Here's another example. 5 is greater than this one. If I multiply by whatever number, as long as it's the same, the resulting thing is true, so you leave it like that. Now, if you multiply both sides by a negative number, the direction of the inequality sign is reversed. You have to reverse it, guys. You have to. Because otherwise it becomes a wrong statement. So you see how this one's true right here. See how 7 is greater than a 4.5, and I multiply it by a -3 both sides. We have to switch the inequality around. We have to. You see from here to here. And this is true. This part is true. Now, if you don't know how to understand about the negatives, how this one's bigger than that one, you can think about it like this. If I give you $50 or $1, which one would you grab? Wouldn't you grab this one right here? Like grabbing, like imagine like the hand, stick your hand grabbing it. You always want the bigger one when it comes to money. Now look at this one real quick. This is how I explain it. And if you don't like it, I'm sorry, but this is the way I explain it. So you should have learned it another way in 6th grade. This one right here, you owe $21 or you owe $13. Either way, you have to owe money because those are your options. Now what I do, I'd rather owe less. So that's how that one is bigger. Okay. If we get a number line, I would go back. I would get first off to a negative 13.5 before I wind up at a 21. Okay. Now the rule is on a number line, if it's further to the right, it's greater. Well, what do you mean, sir? So look at 1 and 2. Which one's further to the right? The 2, right? So that one's greater. Same thing with the negatives. On the number line, if it's on the right-hand side, it's greater than the one on the left. Simple as that. So when I think about numbers, if you kind of forget this part right here, don't worry about the idea. Just think about, would I rather owe this or would I rather owe that? Oh, I'd rather owe that. That's what's greater. That's what you want. Okay? Now the rule is, if you divide by a negative, multiply by a negative, it switches. You understand that? If you multiply by a negative, you see I'm multiplying by a negative, then it switches. Let me go to the rules for the division one. Here's the division properties. Same properties. If you multiply inequality, okay, by a positive number, the resulting inequality is also true. So if I had 4.5, you see that? And it's greater than 2.1, and I divide it by a 3, dividing both sides by the same number, it's still true. Inequality side stays the same. Now if I have this one's true, and I divide by a negative 6, you need to switch around the inequality sign. Same principle, guys, same idea. So if both sides of a true inequality are divided by a negative number, the direction of the inequality sign is reversed to make the resulting inequality also true. So you gotta kind of be aware of that. That's the only rule you need to keep. It's like solving an equation, guys. It's like solving, what we've been doing since the first 6 weeks. Let's jump over here and start working on some examples. First off, they give you a word problem. I'm going to skip the word problem. Jump into here. Now, look at this part real quick. This one's my first idea that I'm working on, the first one that we're working with here. Okay, so look at this. Just humor me. See it as 3r is less than 21. How would I solve that one? Wouldn't I divide by 3? Right? In this situation, I'm going to divide by 3. I'm multiply by 1/3. Okay? And they would cancel out. Do you agree? Multiply by 1/3. You see how division and multiplication are the same thing? So you kind of, same rules apply here. Now, how do I get rid of this one right here? Remember, I multiply by the reciprocal, guys. I multiply by the reciprocal, which is what, 7/3? So you cancel out. This one here is negative, so I'm multiply by a negative, and that's what we're doing here. We multiply by a negative reciprocal of this thing. These would cancel out really good. But guys, please make sure you're multiplying by a negative. Inequality sign, what? Switches. There's your final answer. Okay, the idea is, did I multiply or divide by a negative? Not if I got a negative answer. I don't care about the negative answer. I want to know, did I multiply or divide by a negative? If I did, then the inequality sign switches. Everything stays true here. You come on here, set notation. R is the answer such that R is greater than or equal. Greater than a negative 49. So we go to negative 49. You see how it's going to the right? It goes to the right. I'm going to try these real quick. So let's look at this real quick. I'm going to have n over 6 divided by, less than or equal to an 8. This one's being divided by a 6. So what I would do, multiply. If I multiply by a 6, these would cancel out, to tell you the truth, but still these are negative. So I'm going to multiply by a negative 6. So I'd multiply this by a negative 6. When they multiply by a negative 6, they cancel out the negativeness, slash I'd have n. Since I multiplied by a negative, this thing switches. Negative 48. Number line here, 48, negative. You see this pointing to the right. Again, my variable has to be on the left. I'm going to shade it in and go to the right. Okay, go back and recap. Since it's a negative, I want to cancel that negative out, so I multiply by a negative. Since I multiplied by a negative, this inequality sign switches. Make sure you know that. Here we go. 4/3 negative times a p here, negative 10. So then I would honestly multiply by a negative 3/4, the reciprocal. Multiply by a negative 3/4. 4/3, flip it over, 3/4. You got it? Negative times a negative will give me a positive, and that's what I wanted. Since I'm multiplying a negative times a negative, okay, it becomes a positive p. Since I multiply the negative times the whole thing, this thing switches. What does this give me? And 30/4. Ooh, what is that? 7.5. All right, we'll leave it like that. So p is my answer. So I'm going to go over here, put my number line. We're going to go with 30/4. The variable is on the left. I'm going to go to the left. Equal sign shaded in. No equal sign not shaded in. Here we go 1/5 and greater than or equal to a negative 3. Let's look at this madness. What do I want to do here? I want to get the arrow, right? So on this side here, I would multiply it by 5. Okay, 5/1, guys, which is 5. So you're going to write 5. Multiply by 5. This cancels out, giving me m. I did not multiply by a negative, so the symbol stays the same. Negative 15. Sir, but you got a negative 15. Yes, I did not multiply by a negative, so this thing stays the same. I don't care about what I get as the answer here. I just care about, do I multiply by a negative? If I do multiply by a negative, this thing switches. If I don't multiply by a negative, then it stays the same. Final answer for this one would be 15 here. And you see how my variables on the left here, equal, shaded in, go to the right. Here we have 3/8 less than 5. So we're going to come out here and the same thing. I'm going to multiply it by a reciprocal 8/3. Multiply by a reciprocal 8/3. This cancels out completely. T is no multiplication by a negative, so it stays the same. This becomes 40/3. It gives me a weird number like 13 1/3. So we should leave it like that. So we're going to go with T. We're going to graph this thing. (40/3), and then we're going to go ahead and, ooh, forgot that one. To the left, see variable on the left, that's my arrow, which way to go, left, and then no shaded in, and there it stays. Okay guys, so I just went to the next example in the book. So this situation right here, you have this multiplication, you want to divide, right? Divide to go ahead and get that variable by itself, 60 times t, so you divide by 60. So in this situation, we divide both sides by 60. Guys, we're not dividing by a negative, so the inequality sign stays the same. Over here, I will divide by a negative 7. You see that? Divide by a negative 7. Once we do that, look what happens. See, from facing, I guess, to the right, you can see, it switches because we divided by a negative. Okay? Let me try these real quick. So in the top right here, I would have 8p is less than 58. Again, that's my 8 times p, so I would divide by an 8, divide by an 8. This one gives me p is less than or equal to 58/8. Man, I don't even know what that is. What I can do is divide them by 4, no, 8, no. So I'm just going to simplify this real quick. By 2's, right, it gives me 29/4. So this gives me 29/4. So we graph that one. Okay, variables on the left. I'm going to put here 29/4. And we're going to shade to the left. Arrows pointing to the left. I did not divide by a negative, guys, so it does not switch. I did not divide by a negative, so the inequality sign does not switch. Okay, so let's look at this one real quick. So you have a negative 42 less than or greater than or equal to 6r. So I'm going to divide by 6, divide by 6. Remember, I want the variable by itself. When I put 6 over 6, it gives me a 1. And that's the idea. If I get that, I get a 1r. Remember, we want that. This gives me a negative 7 here. I got a negative, guys. But why didn't I switch here? Why did I not switch? Because I didn't divide by a negative. So it's just come out here, final answer. Add a negative 7. Variable is, ooh, I almost got tricked there. Let me rewrite this one. R, make sure the variable's on the left. Put the negative 7 over here. You see that one right there, guys? How it's eating the 7? So I'm going to come out here and continue to eat that 7, or negative 7. So now this is the one I graph, not this one. That one's going to be, if you did that one, you'd get it wrong. Since the R is on the left now, and now I can say I go to the left. Shade it in, and there it is. Not too bad, right? Okay, let's look at this one real quick. Negative 12h greater than greater than 15. Okay, so I want that variable alone. And look what I'm going to do here. Since I'm going to divide by negative 12, both sides cancels out. We're going to have h. This thing, guys, switches because I divided by a negative. Divide them both by 3, 5 over 4. There it is. Negative 5 over 4. Variable is on the left, so I would shade this way. Oh, no shaded in, no equal sign, but I would point the arrow that way. Next one over here, I'm going to go with negative 1/2 n less than or equal to a 6. I want the n by itself. They're sneaky, guys. They want you to come out here and divide by a negative 1/2. I don't like that. Okay, remember multiplication, division are the same thing. Just multiply this one by the reciprocal, which is a 2 over 1. We don't write 2 over 1, we should write a 2. This right here is situation's a negative, so I'll multiply by a negative. You have to. Okay, now that part cancels out purposely, and this thing switches, and it becomes a negative 12. Variable on the left, pointed to the right. So here, I go to the right. What's wrong with this one? What's wrong with that last one right there, guys? Equal sign, shade it in. Going once, going twice. Okay, that's your video for today. If you understood this, perfect. You have an assignment on Alex. Hold on, let me figure. Okay, Alex, it's called 5-2. Have fun. I'll name it like that. Get it done. Do it to it. Have fun. Enjoy it.